My name is Zane Severance, and today we're going to be solving for the zero of this function using the rational zero theorem. So in the rational zero theorem, we first list all the possible rational zeros using the first number of the equation and the last number of the equation. So the largest exponent is x cubed, and the smallest number is the -6 here. So the x cubed, let's treat it as a 1. 1 can only give us positive -1. So that's pretty simple. So here we have a 6. So that can give us positive -6, positive -3, positive -2, and once again the positive -1. Now there's multiple things we could test in order to figure out what the zero is out of all these problems, but to save time I already know which one it is. I'm just going to give an example of how to plug it in. So the possible real zero that we could use is 2. So what we do to plug this in is we take out the 5, the 2, the 1, and the 6 from this problem and plug it into a chart here. So plug in the 1, 2, -5, and -6. So basically, if you get a 0 at the end of it, then it's successful, and the 0 is a solution. Alright, so to start we carry the 1. Now 2 times 1 is 2, which will add up to 4. 2 times 4 is 8, -5 is 3. 2 times 3 is 6, and -6 plus 6 plugs into 0. So now we know that 0 is a solution of the problem. So we can go in here and plug in the 2. Using x minus 2, and we factor that out of the actual equation. So if we factor out x minus 2, we end up with x squared plus 4x. Oh geez, that's a terrible 4. Plus 4x oh geez, what am I doing? Plus 3 equals 0. Okay? So now we need to factor this binomial here. So we carry down our x minus 2. And we have to factor this. And I just know this, because I already did the math, that x plus 3 and x plus 1 also are equal to that binomial. Therefore, your solutions here would be the opposite of the number in parentheses. So your solution would be 2, -3, and -1. All plug into this problem to provide a solution of 0. So the solution set would be -3, -1, and 2. And those are all the zeros of this problem.